All right, I think we'll get started. Welcome. Thank you for having me at NDC. It's my second time at NDC Sydney, first time speaking. Very excited to be here to talk about single-page applications and how we can make them more accessible. And thank you for coming along to my talk. I know that there were lots of other really good talks on in this time slot, so appreciate that you care enough about accessibility to come and learn a bit more about it. My name is Jess Budd. I'm a senior software engineer at a Sydney company called HireUp, who is an NDIS registered provider. Since Twitter imploded, I joined all the things, so you can find me anywhere now. I'm basically just hedging my bets to see where the tech community kind of lands. But I popped my handles at the bottom of all the slides, so if you'd like to reach out, any platform of your choice, I'll be there and I'd love to hear from you. Previously, I've worked for the Centre of Inclusive Design as a digital accessibility consultant. So I'm a bit of an accessibility nerd and I'm a huge lover of Lego. And just to give you a bit of an idea of how much I love Lego, this is a photo of me holding the Lego Masters Trophy Cup with the winners of season 5 of the Australian Lego Masters show. Does anyone watch Lego Masters? Yeah, a few people. Yes. I was so stoked. My husband says I didn't look this chuffed on our wedding day. So I was really, really chuffed. So does anyone recognize this guy? It's Tim Berners-Lee, the inventor of the World Wide Web, the reason we all have jobs today. And he had a vision of a universal web where everyone has equal access regardless of income, regardless of location, regardless of ability or disability. And it's a great vision. But we're kind of messing it up, mostly with JavaScript. HTML is generally pretty accessible out of the box. So browsers and assistive technologies generally know what to do with it. But since we've all started using JavaScript frameworks, the web has become a little less accessible. But it doesn't have to be that way. There's nothing inherent in React or Vue that prevents us from building accessible web apps. It's just that sometimes we as developers don't know what we need to do to make our apps more accessible. So today we're going to talk about how we can still use all these cool frameworks while still fulfilling Tim's vision of an accessible web for everyone. Can I get a show of hands? How many people in the room are using JavaScript frameworks either day-to-day or in your side projects? Oh, good. Yeah, I'm glad it's pretty much everybody. I was a bit worried that .NET crowd, there wouldn't be a lot of people. So the good news is there is something inherent in single-page apps that is a plus for accessibility. So the modularity that single-page apps provide means we can build an accessible component once and then just reuse it over and over again. So this is especially true if you use a design system in your organization. And everything just becomes a lot easier if we can get our foundational components compliant. So there are a lot of JavaScript frameworks out there. A new one's probably been invented since we've been in this room. But the concepts we'll cover today should apply fairly universally. The implementation just might vary between frameworks. In this talk, I'll be showing a mix of code samples from both Vue and React, just because those are the frameworks that I'm most familiar with. But like I said, most of the concepts are applicable to all of them. And web accessibility is a big and broad topic, but today we're going to focus on things that are generally within the control of the developer and things that give the highest amount of impact for the lowest amount of effort. Some of the things we'll cover today are simple and they are easy, and they could be considered low-hanging fruit. But low-hanging does not mean low impact. Some of the most basic changes we can make to our applications can be the difference between usable and unusable. Before we dive in too much, I just want to take a moment to set a shared understanding of what we mean when we talk about making something accessible. I think the simplest definition is that web accessibility is the practice of removing barriers to using your website. So making it easier for people with disabilities to consume your content, to buy your product, to complete the actions they came to do and get on with their day. But accessibility doesn't only benefit people with disabilities. It benefits all of us. A lot of the things we take for granted today were first built for people with disabilities. So, for example, speech to text, SMS, automatic doors, and audiobooks were all designed for people with disabilities. So when we design and build our code to be accessible for people with disabilities, we also help people experiencing a temporary or situational impairment. So subtitles help both your hard of hearing and deaf users, as well as people who are in a loud environment. Sufficient colour contrast helps both your low vision users as well as people who are trying to use their phone in bright sunlight. Around the web, you might hear accessibility referred to with the acronym ALLY. This term was coined because there are 11 letters between the A and the Y, and accessibility, I always forget how to spell it. This was really helpful for me, but also it's a bit of a mouthful to say. According to the Australian Bureau of Statistics, there were around 4.4 million Australians living with disability in 2018. So that's around 17% of our population, or a little over 1 in 6. And I'm sure no one in this room wants to be alienating up to 17% of their users. You wouldn't be here in this room if you did. So let's just do a quick run through of the broad categories of disabilities we want to think about when we're creating our platforms. The most well-known is probably visual. You might think of blind users. 285 million people worldwide have some kind of vision impairment. So from full blindness to lower tunnel vision or even colour blindness. There's auditory disabilities. 1 in 6 Australians are affected by some level of hearing impairments. This can be as much as profound deafness or even lower levels of hearing loss. Personally, I'm actually included in that 1 in 6. I thought my kids were just mumbling all the time, but it turns out I actually have permanent hearing loss, most likely from listening to very loud heavy metal music in my youth. It's only the high upper frequencies I'm missing, but those frequencies are really important for deciphering speech. So it means I can have trouble understanding people in loud environments. You can't whisper secrets to me, and captions and subtitles are my friend. Another broad category is motor impairments. This includes a wide range of conditions that can affect a person's physical ability, from loss of limbs to chronic arthritis or cerebral palsy. This group uses the widest range of assistive technologies to access the web. So that could include things like voice recognition software, eye tracking, head wands, and adaptive keyboards, to name a few. And the last broad category is cognitive. So these are disabilities that impair a person's memory, attention, learning, perceptions, or thoughts. It includes conditions like intellectual impairments, neurodevelopmental disorders, and dementia. And you might have noticed that a number of the conditions I've mentioned are commonly found in people as we age. And if we're lucky, we're all going to be old someday. So visual and hearing deterioration plus physical and mental decline are all expected as we get older. And I don't know about you, but as a millennial, I don't plan to stop using the web just because I get old. So let's all be kind to our future selves as well. If you've ever needed to make your website or app compliant, which is pretty common if you work in the government or banking or health space, you may have heard of the Web Content Accessibility Guidelines. It's often referred to by its acronym, WCAG. These are a set of guidelines created by the World Wide Web Consortium in 1995. They've been updated a few times since then. The latest version, 2.2, was just released late last year. And these are technical standards which platforms are measured against when being assessed for accessibility, or when they're being sued for lack of accessibility. The guidelines are a list of success criteria to meet with in-depth technical documentation on how to meet them. It is not a light bedtime read, but it is an excellent reference if you want to deep dive on a specific requirement and different techniques on how to meet the requirement. And don't worry, I know this looks super daunting, but there are like plenty of resources out there that sort of break this down into sizable, easy to understand chunks. And I'll link to some of those at the end in my resources. So WCAG is broken down into 4 main principles and often referred to with the acronym of PAW. P stands for perceivable. So this means that information is presented in a way that can be accessed or transformed for the different senses. So for example, a video having captions or the text added to the page as HTML instead of an image of text. So assistive technology can read it out. The second principle is operable. So this just means your interface can be fully operated in multiple ways, not just a single method like a mouse. So examples of this include like a drag and drop interface that also has keyboard controls, or an app with a shake to win functionality that can also be activated with a tap. The third principle is understandable. So this relates to how the information is presented and how clear the functions are. Examples of this are using plain, understandable English and written descriptions of information contained in charts or graphs. And the last principle is robust. So you can think of robust as being similar to progressive enhancement. It's making sure all your code and functionality is supported in a variety of older browsers and systems before adding in any optional extra touches. And each of these WCAG success criteria will relate to one of these 4 principles. WCAG also has 3 levels of adherence. Level A, this is your must-have bare minimum. So when we don't meet this standard, people with disabilities are likely to have trouble accessing your application or having trouble using it. Double A, so this is generally what we aim for as an industry. When we meet this level, most people with disabilities will be able to adjust their settings to be able to use your application fairly comfortably. And level AAA, so this is the highest and strictest standard of accessibility. It's recommended when your primary audience is people with specific disabilities. So throughout this talk, I'm going to reference the specific WCAG criteria that applies to the technique we're discussing. So to kick off, we're going to start with HTML because meaningful markup is the foundation of an accessible website. You know when I said at the beginning that HTML is pretty accessible out of the box? Well, that's half true. It is when we use the right HTML elements. Unfortunately, good HTML has become a bit of a lost art in the days of JavaScript engineering. But getting back to these basics will give us the biggest bang for our buck in making an accessible app. Meaningful or semantic markup, it simply means using the native browser elements and controls to convey the meaning, purpose, and structure of our content. If you saw Mandy's excellent talk on Wednesday, you'll know that HTML was designed with built-in meaning and functionality. And to understand why the correct HTML is so important, it's helpful to understand how a screen reader user navigates a web page. So just as sighted users can scan a site to quickly get the relevant information, screen reader users can do a similar thing. They can use what's called a rotor inside the screen reader to create lists of different information within a page, cycle through them, and navigate to specific items quickly. For example, a list of all the headings on a page, or all of the links or buttons or landmark roles. But if we haven't used HTML in the way it's designed, we actually remove that ability. So people are forced to read out the entire web page to find what they're looking for. Another group that can be affected by non-semantic markup are keyboard users. When we use elements that don't have the appropriate accessibility features built in, we can prevent keyboard users from being able to access and activate those web controls. And accessibility isn't the only benefit you'll get from using HTML correctly. It's great for SEO as well. Assistive technologies access your page in a similar way to search engine crawlers, relying on the contextual information provided by the markup. So for example, interpreting that a H1 is the most important content on the page, or that the text within an anchor element describes the purpose and relationship of that link. If a screen reader doesn't understand your content, there's a good chance that Google can't either. So here we've got an example of an inaccessible card component. And I'm sure we've all seen markup like this before. We've got a wrapper div for styling, a heading div, a paragraph div, a button div. This is what we affectionately call div soup. And it's not just divs that are a problem. In modern web development, we've been given this great power to create custom human readable elements or components. And what do we know comes with great power? Great responsibility. So yes, we can create a JavaScript component called Totally Awesome Button, but that doesn't mean we always should, because these custom elements have the same effect as using divs. They have no default meaning and don't pass any contextual information to the accessibility tree unless we add it ourselves. So we just need to ensure we're using appropriate HTML elements inside of our custom components. So here we've got a more accessible version of our card component where we've replaced the wrapper div with a list item so we can logically group this card with the other cards surrounding it. We've replaced the heading div with a H2 element, so this will now appear in a screen reader's list of headings for easier navigation. We're now using a real paragraph and a real HTML button element. And so let's just take a moment to talk about HTML buttons. They're actually really amazing and powerful. So by default, they're focusable by the keyboard. They can submit data to a server and reset forms. They can be disabled by the disabled attribute and styled by their active, focus, and hover states. And their role is automatically reported to the accessibility tree. So let's take a look at what we need to do to make our button div accessible. First, we need to make it focusable with the keyboard because divs aren't focusable by default. Then we'll need to give it a role of button, so assistive technologies can announce it as a button. Without this, a screen reader user may not know that this element is meant to be interacted with. We'll need to add a key up or key down listener because divs have no synthetic click activation. And then we also need to code the JavaScript handler to perform whatever action clicking would do. And so we could do all this, or we could use a HTML button and get that behavior built in for free. So next time you need an element to do something like trigger a pop-up menu, open a modal window, toggle an interface, a button is probably the right choice. Using appropriate HTML touches on a number of WCAG success criteria, including info and relationships. So this is about all the information that is conveyed visually, so like heading styling, is also conveyed programmatically. Keyboard, so this is pretty straightforward, just saying that anything that you can do with a mouse, you can also achieve with a keyboard. And name role value. So this criteria relates to making sure interface components have a name and role that can be programmatically determined, which is what we were talking about with the button a moment ago. And you might notice that these are all level A criteria, so they are really critical. Next, let's talk about forms. The internet is full of forms. Newsletter subscriptions, contact forms, product signups, shopping carts. You might notice that these are a lot of things that make your company money, so important. There are a number of ways we can make our forms more accessible. And the first I want to talk about relates to form inputs and labels. And I can break it down into two simple, easy rules to remember. Inputs must have labels, and those labels must be linked. Here we've got a visible label, which is always a good start, but the label and the inputs aren't actually linked in any way. So this means when a screen reader lands in the input, the label is not announced. So the screen reader will say, edit text, blank. They'll know they're inside a text input, but it's not clear what that text field is actually for. Contrast this with an explicitly linked label. We do this by adding a for attribute to the label and matching ID on the input. And when a screen reader lands in this input, the label will announce edit text, Lego character. So it's now clear to the user what the input is asking for. Now, I did say that the IDs must be unique on a page. So one of the reasons we all love single page apps is being able to create and reuse modular components. But this also means you won't always know what other inputs or forms are going to be appearing on the same page. So if your ID is something fairly generic, like address or name, it may not be the only address or name on the page. So we can get around this by importing a package like UUID, which generates unique identifiers for us. We can create a variable that combines a human readable name like address with a unique identifier suffix, and then pass that variable into the label and input to ensure there won't be any duplicates with other inputs on the page. And you might be aware of another approach where a label can be linked implicitly. This is achieved by wrapping the input inside of the label, and that does sound a lot more straightforward. However, this method doesn't have as good support with assistive technologies, so it's always best to explicitly link if it's possible. And so what if you've been given a design and it doesn't actually have visible labels? This can be a problem for people who use screen readers, as well as people with cognitive impairments who might not be able to infer the information from the context. It was really common to see about 10 years ago, and thankfully we don't see this as much now, but it does still happen. Not all designers are aware of how important visible labels are for accessibility. So first thing I would say is have a chat with your designer. Most designers are very reasonable. They want to have the best experience for their users. So they'll probably be pretty happy once they know how important it is to add those in. But if for some reason you're getting a lot of pushback or it's not possible for some reason to have visible labels, you as the developer still have the power to make this more accessible. So we can add a label into the HTML that is accessible to assistive technology while hiding it visually with CSS. If you're using a CSS library like Tailwind or Bootstrap, they already have a built-in utility class for this purpose. And if not, you can easily roll your own. The CSS on screen is a common method of doing this. It uses a combination of absolute positioning, fixed height and width, overflow, and clip path. It just moves the content off screen without affecting other elements on the page and will still be announced by a screen reader. Including labels meets the WCAG success criteria of labels and instructions. And again, you might notice that this is a level A criteria. And you might be wondering about placeholder text and if they're a valid alternative to labels. Unfortunately, I'm sorry to say they are not. Placeholders are popular because they save space and they're minimalist. However, they're not accessible for a range of disabilities. They're not reliably supported by different assistive technologies, so they may not be announced to the user. And they can be problematic for people with cognitive impairments who can forget what the prompt was when they click in and it disappears. They rarely have sufficient colour contrast for people with visual impairments, but if we increase that colour contrast, then we make a situation where the users might mistake the input as already being filled in, increasing the likelihood of submission errors and frustration from the user. And this would be especially true of anyone who might be using high contrast modes. And so all of these reasons are also why we shouldn't be relying on placeholders for helper text. Helper text provides more information to users on how they fill out a specific field. But if the information is important enough to be included on the page, it should be permanently visible and available to assistive tech by including it in a paragraph text below the label. Which criteria this comes under does depend on the context. So if not following the helper text is going to give the user a form validation error, so for example, this field only accepts 9 digits, that would come under labels or instructions. But if we're simply offering guidance on how the user can get a better experience, but it won't stop them submitting the form, this comes under the AAA criteria of help. An example of that is when you're saying suggestions on how to write a good profile bio to increase the user's chance of a successful match. Another benefit of linking your labels and your inputs is that it increases the size of the touch target. The touch target, when not linked, is just the input itself. So think a small radio button or checkbox. But when we link our labels and our inputs, that touch target then increases, now includes all of the label area as well. So imagine you're a passenger in a bumpy car. Which one would you rather be trying to click? This increased area can make a huge difference for people that have trouble making precision movements. For example, somebody with hand tremors. And this helps us meet two success criteria. Target size minimum is the AA criteria, setting out a minimum target size of 24 by 24 pixels. And then we also have the more strict AAA criteria, which sets out a minimum touch target of 44 by 44 pixels. Another way we can make our form inputs more accessible is by enabling autocomplete. We can do this by adding the HTML autocomplete attribute to the input. And this encourages browsers to autofill known answers, and it can also allow assistive tech to customize the display. For example, showing familiar icons next to input fields to help users that might have difficulty reading, like a birthday cake could be shown in front of an input with an autocomplete of birthday. And this helps us meet success criteria, identify input purpose. Next, we'll talk about visible focus styles. Focus indicators are the styles applied to interactive elements when they receive a user's focus to show where they are on a page. They help sighted people that are using a keyboard or a voice input or some other method that's not a mouse. And they can help people with attention or memory issues that may get distracted and then have to come back. Each browser comes with its own default focus style. It's often a thick blue outline, but this will vary depending on the operating system and the device that you're using. Ever since CSS resets became popular in the mid-2000s, there's been a tendency to remove these defaults for consistency between browsers, but also because they're considered ugly. But removing the focus outline entirely is like removing a wheelchair ramp because it doesn't fit with the aesthetic. When we remove these focus indicators, sighted people not using a mouse can get lost. Imagine you were navigating a retail website searching for a specific item and your mouse pointer just disappeared. And to make it more difficult, there were no hover styles on any of the links or buttons. That's similar to the experience of a sighted keyboard user when the focus indicators are missing. It's a really confusing experience, and there's no way of knowing where you are on the page or what link or button would be executed if you hit enter. So instead of removing the focus outlines entirely, we can replace the default focus styles with our own on-brand styles with the focus visible pseudo-class. Focus visible only applies styles when the browser thinks it makes sense to, based on some heuristics it determines, like a non-pointer input being used. WCAG success criteria focus visible states that any interface operable with a keyboard must have a focus indicator that's visible. But it doesn't actually set out any rules around how that indicator is styled. The non-text contrast does specify a 3:1 contrast ratio for interactive components and their different states, but technically you could meet that criteria by a subtle change in like background color, as long as that state has contrast with its background. But that can still be really easy to miss. So in the latest WCAG 2.2, they did add a new criteria specifically to address the focus indicator appearance in relation to its non-focus state. This is a AAA criteria, so may not technically be required for your compliance, but it's a really great guideline on the best practice and how you can help a range of users. And that criteria defines a minimum level of visibility for both size and contrast, but it kind of boils down to make it big, make it stand out. The criteria says the focus indicator needs to be at least 2 pixels thick, and it needs to meet the 3:1 color contrast between the focused and the unfocused state. And although we can use different focus styles on different elements, for example, we could change the background colors on buttons and add a border to links, the easiest way to achieve this is with an outline on everything. And outlines are great for a couple of reasons. So they can be applied without causing any significant changes to those elements, which makes them simple to apply across a lot of different types of elements. Because the outlines aren't part of an element's box model, it won't cause any layout shift when we apply it. And because outlines aren't removed by forced color mode like Windows high contrast, then we won't have the same effect as background colors and borders, which can be removed. Another tip is to use an offset by a few pixels. Adding an offset means we don't have to worry about the contrast ratio between the element and the outline making it easier to see and easier to pass. The next topic is one of the main challenges that are really unique to single-page applications. And there are fundamental differences in how routing works in a single-page app versus a traditional multi-page app. When we visit a traditional multi-page app, the client sends a request to the server, and the server goes to the database and gets the content, and it builds out the page and sends back all the HTML, CSS, and JavaScript your website needs to build that page. When we click a link, we basically do the whole process again. So the client sends a request to the server builds the whole page out, and it sends it over to the client, and this triggers a full page refresh. And when the page refreshes, the page title changes, and the keyboard focus is reset to the top of the page. And this triggers a screen reader to announce the new information, including the new page title and the new content. To contrast this with a single page application, generally in this situation, the browser sends a request to the server. The server sends back a little bit of HTML and CSS and a whole ton of JavaScript. And the browser then uses all this information to build out the page and render it. When we click on an internal link, the browser already has most of what it needs to build out the new page. So it just asks the server for a little bit of data it needs from an API. The server sends back some data, usually in the form of some JSON, and then the browser rebuilds the component it needs itself. So we're only updating part of the page. So the shell and that's just often the header and footer remain. The page title doesn't change, but the component the user was on is gone. And the user focus usually just gets dropped to whatever's beneath that, so the footer. And in the case of screen reader users, it's difficult to know what, if anything, has actually changed. So we need to recreate a bit of that traditional behavior by updating the page title and managing the keyboard focus. We'll start with updating the page title. In single page apps, we tend to set the value once in the global template and then don't really think about it too much again. And just to be clear, we're talking about the document title that shows in your browser tab, not the page heading within the main page content. This is the information announced by a screen reader when the page loads. So it gives context of the page we're on, but it also acts as a confirmation of a change in page context. So how do we update the document page title when the page itself isn't actually changing? One approach is to use lifecycle methods in combination with vanilla JavaScript. So in a React functional component, we might use the useEffect hook. In Vue, we might use the mounted lifecycle hook. And another way we can do this in Vue is with its official router. Vue router gives us the ability to specify our page meta values at the time we define the routes. And it also has a powerful feature called navigation guards, which are functions that automatically get called before or after navigation to a route. And so in this code, we use the before each guard to set the document title to be passed in, to pass in the meta title or a sensible default if we haven't passed anything in. Another approach to updating your document title is using a package like React Helmet or Vue Meta. You might consider an approach like this if you have a lot of meta tags that need updating. So, for example, if you've got a marketing website, maybe that needs information from a headless CMS to update a whole bunch of social media or search engine tags, you might consider that approach. Updating the page title assists screen reader users to know where they are, but it's also helpful for people with cognitive disabilities and people that tend to have multiple tabs open at a time. Imagine you had all these different email tabs open, but the title was the same on each one. It would be really difficult to remember which tab was for which content. And so accurate and meaningful page titles is required under the WCAG criteria page title, again, a single A level. So the other one we wanted to talk about was the focus management. And focus management is when we dynamically control a user's keyboard focus programmatically. So this should only be used sparingly and generally only in response to a user's action. When a user clicks a link to navigate to a new route, that's a time when it does make sense to actively manage where that keyboard focus is going to. And so there's two sort of common strategies here to consider. The first is to simulate a traditional page load by faking a regular page navigation. And that includes announcing the page title using a live region and setting focus on the body element. The second option takes an approach that's a little more natural to the single page app paradigm. Instead of making the application behave as a traditional app, we can make the single page app more user-friendly by setting focus to where we know the user wants to go, which is the new content. There isn't a hard right or wrong choice here, but user research by the Gatsby team suggests that option 2 is a little more intuitive for a broader group of users with disabilities. So that's what we're going to go with for this example, and I'll link to their blog post about that in my resources as well. Now, not all elements can receive focus by default. Generally, it's limited to like links, buttons, form inputs, but we can manipulate the focusability of an element using tab index. And tab index has 3 possible states. A tab index of 0 makes an element reachable by the keyboard in the order it appears in the DOM. A tab index of negative removes the item from the normal focus order if it was in the normal focus order. And it also allows us to send focus to it if it's not normally focusable. The last possible state is an index of greater than 0, so 1 or 5, 10. This jumps the item in front of the other items in the normal tab order, inserts it into the order. And this is pretty much never a good idea. So it's generally an anti-pattern. I recommend you don't do it, but I just mention it here for completeness. The Gatsby research suggests there's a few different places we could send focus to, including a dedicated skip link or page wrappers. But for this, I'm just going to use page heading as an example because I think that's the easiest. Pretty much every page has a H1. It's the easiest implementation, I think, than adding an extra thing that wasn't already on the page. So to send keyboard focus, we're going to need to give it a H1. A tab index of -1 because we want it to be focusable, but we don't want it to appear in the tab order. We use the React hook useRef to add a reference to the heading. And then we use the hook useEffect to set focus on the H1 when the component mounts. Now, headings aren't normally focusable, and it's not standard for elements to receive focus on page load. So having a visible focus indicator in this instance is probably going to be a bit confusing. And I'll admit it doesn't look amazing either. So this is one of those rare times it is okay to remove the visible focus. Another time we need to actively manage the user's focus is when we're working with modals. When we develop modals, we need to do 3 things. When the modal opens, we need to move keyboard focus to it. And while the modal is open, we need to trap keyboard focus within it so keyboard users can't access anything outside or behind the modal. And when the user closes the modal, we need to return keyboard focus to where it came from. Years ago, Rob Dodson, who's a former Google employee with a fantastic accessibility series on YouTube, wrote, "Modals are actually the boss battle at the end of accessibility." And he was onto something because until recently, making a modal accessible was really difficult. And your best bet was to just use an accessibility-focused ready-built plugin than try to do it yourself. Thankfully, it is a lot easier these days. And this is thanks to improved browser support for the native HTML dialog element. Although dialog was first dropped in Chrome in 2014, it took 8 years to gain support in all of the major browsers. And so this actually only happened in early 2022. The native dialog element does the 3 things that I already mentioned that we need modals to do to be accessible right out of the box. The dialog is opened using JavaScript, using the show modal method, and closed using the close method. It can also be closed by hitting the escape key. This is a very standard accessibility feature expected from keyboard users, and we used to have to add this in manually, but now we get it for free. And the dialog element also lets you configure which element should be focused when it opens with the autofocus attribute. So by default, it focuses the first focusable element in the modal, but you might want to customize this for your use case. For example, if the first focusable element is a destructive action like delete, you might want to autofocus the lesser destructive action. Or for example, if you've got a modal, might be T's and C's with an accept button and they're supposed to scroll through and read the T and C's, you might want to send focus to, say, the heading instead. The close method can also take an optional reference to a different return element if there's another element that makes more sense, but in most cases, the default is going to be suitable. The modal itself can be styled with the pseudo selector modal, and everything behind the modal can be styled with the backdrop pseudo element. If you need to create a custom modal, so if dialog doesn't work for you for some reason, it is now easier to roll your own accessible solution thanks to the introduction of inert. Inert is an HTML attribute that disables user input for an element and all of its children. It also hides everything within the element from assistive technologies, similar to adding an aria hidden or true. So this is what we can add to the main element of the page while a custom modal is open to ensure that nothing outside or behind it can be reached. And despite a polyfill for inert being around for many, many years, it's only recently been added to the browsers. And this is thanks to all the big players working together on shipping dialog, which uses inert functionality behind the scenes. And so using these techniques helps us to meet WCAG criteria focus order, which says that focusable components need to receive focus in an order that preserves meaning and operability. And so lastly, we're going to finish up talking about testing. There's two main categories of testing, automated and manual. So you'll notice this is not automated or manual, this is automated and manual because they're both important pieces of the Ali puzzle. We'll start with automated tools that are inside our code editor. And what would a tech talk be at NDC or in 2024 without mentioning AI? So over the last year, I, like many other engineers, have been trialing AI coding assistants. And GitHub recently shared a prompt you can provide their Copilot to help you with accessibility. And I'll have a link to the article in my resources, which includes the prompt, because it's really big and really long. So don't feel like you have to remember it or take a screenshot because it'll be in the resources. So it is a lot, but it does follow some pretty standard approaches to prompt engineering. So first, we provide some solid context and background to help narrow down the scope of solutions. Then we tell Copilot what its role is and set expectations about what kind of feedback we're looking for. And next, we're telling Copilot to reference specific resources that we know are reputable and good quality. And then we ask for additional resources and reference, partially so we can learn more, also so we can verify and double check its answers it's given us, because we all know sometimes AI makes stuff up that sounds very believable. And the last one gives a final set of requirements that reiterates the scope that should be considered when providing code suggestions. And if you ever want to check that Copilot is still giving answers with this prompt in scope, you can just ask it to confirm. So I have used this this prompt, and I was actually very pleasantly surprised at how well it worked. Everything it told me was correct. So this is probably a tool that would be worth adding to your arsenal. Still inside of our code editor, we've got linting. So most of us are probably already familiar with or already using ESLint. An extension to this is called ESLint plugin JSX Ali. It's a mouthful. And it runs a static analysis of your JSX for accessibility issues in React. And these will appear as errors, and warnings are just alongside all of the other ESLint warnings. It comes built in to create React app by default, and it's got over 11 million weekly downloads. And Vue also has an equivalent plugin. There's probably also equivalent plugins for Angular and all of the other frameworks. So these look for around 40 different issues and include common mistakes like images without alt attributes, links without accessible content inside them, mouse events missing the corresponding key events. So this tool can help us identify any accessibility issues inside of our template, but it's not able to test any of the rendered HTML output. So this is where an accessibility testing library like Axe Core from DQ Labs comes in. This is available as a wrapper for both React or Vue. And accessibility issues are shown in your console and given an importance rating to help you triage the issues that it finds. Earlier, I mentioned an accessibility tree. So this is a lot like the document object model or DOM tree that you're probably already familiar with. And browsers create the accessibility tree based off of the DOM tree. And it's used by accessibility APIs for assistive technologies like screen readers to consume. And you can inspect the accessibility tree in your browser DevTools. I know you can do this in Chrome and in Firefox. I'm not 100% sure about other browsers because I don't really use them. Report back if you know that they're in the other ones. And so in this example, we're inspecting a button element. So we can see the name and the role being passed through and that it's focusable. If you were looking at a div, you'd probably see nothing's been sent through. And this tool can be really useful when you're developing complex interactive components and you want to see visually sort of what's happening under the hood. Jumping outside of our immediate dev environments now, there will be times when you want to assess the accessibility of a full page or a site or everything together. And there's heaps of tools for this, but two popular options are Wave and Google Lighthouse. Wave is a free browser extension developed by the folks at WebAIM. It can generate reports and it can also add visual markers over your site to indicate where it's found relevant information. And you can just click on the overlaid controls for more info. Google Lighthouse is a suite of auditing tools built into Chrome DevTools. The Lighthouse accessibility audit gives a score out of 100, which is a weighted average based on Axe user impact assessments. And on the topic of Lighthouse, I just wanted to share with you a blog post. It's a few years old now, where a developer named Manuel Matsuchevich, I'm sorry, I probably butchered that, aimed to build the most inaccessible site possible while achieving a perfect Lighthouse score. And I'll link this blog in my resources as well. But the gist is that he was able to remove access to the content for mouse users, keyboard users, sighted and non-sighted, basically everyone, while still getting a 100% score with a visually blank page. You couldn't even read the HTML by inspecting element. Now, the point of his post was not that automated tools suck. It was just that automated testing are just the first step. It shortens the feedback loop by allowing us to spot issues during development, but it can only catch 20 to 30% of accessibility violations. That's where manual testing comes in. There are two main tools we use for manual testing. The first is one we all already have. It doesn't require any special skills. And that's your keyboard. All you need to do is use a website without using the mouse. So what are we looking for? We want to see where our keyboard focus is at all times. We want to make sure that the tab order makes sense. You're not jumping all over this place. We want to check that all the interactive components can be accessed. For example, date pickers are fairly notorious for having trouble with keyboards. And we just want to make sure that everything that we can do with a mouse, we can do with a keyboard. So after we've tested with the keyboard, it is great to run through with a screen reader, particularly when developing interactive components that have different states that need to be announced, like whether something's expanded or collapsed. And there's three sort of main players in the screen reader world. JAWS is the most popular for a person's primary screen reader. This is available to purchase outright or as a subscription for Windows. It's pretty expensive as an option, so you're probably not likely to test with this yourself unless your work is paying for it. NVDA is a free open source screen reader. It was developed by two blind Australians, and it also runs on Windows machines. If you don't want to download and install anything, both Apple and Windows both have built-in options available. VoiceOver is built into Mac OS devices and Narrator is built into the Windows operating system. Neither of these are heavily used as a primary screen reader, but so 6.5% for VoiceOver, and I didn't put it on the slide because it's so small, 0.5% for Narrator. But those numbers do go up when you look at the occasional usage versus the primary screen reader usage. So I would say those two options are still better than not testing at all. It can be a little daunting at first while you're getting a hang of the controls because I don't think they're particularly intuitive. So I do recommend just like having a beginner's guide up while you're using it, and I'll link to some of those as well in the resources. And given over half of the web traffic now comes from mobile phones, you might want to like to test on a mobile device as well. VoiceOver is what you'll use on iOS, and on Android, you'll use TalkBack. So both of these are built into the operating system, so you don't need to download or install anything, and I'll add some resources for those as well. Unlike desktop, Apple is the clear winner of market share on mobile, with only 29% of users using Android over iOS. And all these stats are taken from the WebAIM Screen Reader survey released in 2021, which I'll also add. But the latest survey is actually coming out in a few weeks, and it's got heaps of different stats, which are really interesting. So when we were testing with a screen reader, we want to be testing like things like, are all the buttons being announced correctly, or are they just saying button? Does the link text make sense out of context, or are you hearing a lot of read more, learn more, and you wouldn't know what they were about? Form labels being announced, and again, those interactive component, is something collapsed or expanded and things like that. So that kind of wraps us up. So just to reiterate and summarize on these things that developers can do to make our apps more accessible. So making the most of HTML and its built-in functionality, linking our form labels with inputs, updating page titles when we were doing routing, managing the user's keyboard focus, and using the available tools for our testing. And before we all head off to lunch, I just want to leave you with a final thought. The web does not just connect machines, it connects people. That's who we're creating things for, right? People. Humans are a really diverse bunch with diverse needs, and not everyone accesses the web in the same way. And when we use the techniques we've covered today, you're not just writing code, you're making the web a better place. Thank you for having me. I don't want to keep anyone from lunch, so if anyone has any questions, feel free to reach out to me on all of these socials, or just one of them is fine, or just come talk to me after. I'll be around until 3:30 and before I have to catch a plane. So happy to have a chat with anyone who wants to talk more about this or have a question.